Hello everyone, welcome to Roots of Unity. I am Marzukh and today we will continue vectors. So in the last video we covered some basics of the vectors including vector addition, subtraction and all of those in 2D vectors. Today we're going to learn about how to calculate the magnitude of a vector, unit vector and an equation of a line in vector form. But before we proceed any further, it's time to switch to 3D. So what's the difference between 3D vectors and 2D vectors? Well, in the 2D plane, there was the x and y axis, right? But in the 3D plane, there's another axis called the z axis, which faces away from both x and the y axis. So if this is the x and y axis, then the z axis is this one. In computer simulations, this can be accurately shown. However, I don't know about you guys, but I cannot draw that in my copy. In fact, no one expects you to either. If you draw the x, y, and z axis like this, then it's good enough. Okay, so for instance, a 3D vector 1, 2, 3 would be represented as I plus 2j plus 3k. What's k? 1k basically represents 1 unit in the z-axis. We would draw it like this. 1 unit to the right in the x-axis, 2 units to the top in the y-axis, and 3 units frontwards in the z-axis. Out of the plane. We call this out of the plane when it's facing towards you, like out of the page. Okay, so roughly, this is the vector. You don't have to be accurate about it. Anyways, moving on. In the last video, I've talked in brief about what the magnitude of a vector is. What is the magnitude of a vector? Basically, it represents the distance covered by the vector in the vector's direction. We have a word for this, called the displacement. For instance, AB is the vector 2i plus 2j. And AB, we write the magnitude of AB in this way. This is the magnitude of the vector AB. The AB vector covers a displacement of 2 units. So how did I calculate this? Well, you can see that this forms a right-angled triangle, right? And this vector is the hypotenuse of this triangle. So we can just use Pythagoras' theorem to find out the distance. 2i plus 2j, so 2i would represent 2 units on the x-axis, and 2j would represent 2 units on the y-axis. So using Pythagoras' theorem, we calculate this to be 2 root 2 units. What about a 3D vector? For a 3D vector, we can calculate the magnitude in the same way. For instance, let's say a 3D vector is I plus j plus k vector. We can calculate the magnitude of the vector in the following way. It's that simple. Now, what is a unit vector? A unit vector is a vector whose magnitude is 1 unit. So for instance, the unit vector of AB would be such a vector in the direction of the vector AB whose magnitude is 1. So the vector AB is, equal to the vector AB. Now we have learned the unitary method, right? Basically, if 100 centimeter makes 1 meter, then 1 centimeter is 1 by 100 meter, right? That's basically the unitary method. So, to find out the unit vector for AB, we simply divide the vector AB by its magnitude. What this does is basically, it splits the vector AB into equal parts. And each of these parts has magnitude 1 only. So the unit vector is 1 by 2 root 2 into 2i plus 2j. Let's now verify that the magnitude of this unit vector is indeed 1. Okay, so modulusing this, since 1 by 2 root 2 is a constant, I can just keep it outside the modulus sign. And now, all I gotta do is modulus this 2i plus 2j. However, we have already calculated this, and it is none other than 2 root 2. 2 root 2 and 1 over 2 root 2 cancels out, thus giving us 1. Okay, so we have learned the unit vector. But what's the point? Well, we'll learn more about the applications in the upcoming videos. Now, we will write an equation of a line in vector form. Let's say this is the line which passes through the point A, which is 0, 2, 1. and as a direction vector 2, 2, 2. What's a direction vector? It basically points the direction the line will go along. We will write the equation of the line in the form r equals to 0I plus 2j plus k plus lambda into the direction vector, which is 2I plus 2j plus 2k. Basically, this means that for a certain value of lambda, the resulting vector is the r vector. What is lambda? Well, it's just an arbitrary variable. So now, for all values of lambda, if the r vectors are plotted, it will result in this following line. We can take lambda as something positive, something negative, any value. If, however, instead of the direction vector, there is another given point, then we can simply calculate the direction vector and then use one of these points as a reference value. For instance, let's say a line goes through the point 0, 2, 1, and 2, 4, 3. To find the equation of the line going through these points, let's first find the direction vector. We subtract these two vectors, which is 2I plus 2j plus 2k. Ooh, coincidence? I think not. Now we take one of these points as a reference factor. I'll take 2, 4, 3. And now r equals to 2, 4, 3 plus lambda into the direction vector, which is 2I plus 2j plus 2k. It's interesting to note that this line is the same as that line. In fact, vector equations are not unique, meaning the same line can be rewritten in various forms. Anyways, that's all for today. My name is Marzukh, and this was Vectors. See you later.